Hi guys, this is Coach McCullers. This is one of our final videos talking about the distance formula. What we're going to do is we're going to find the distance between 2 points on the coordinate plane. Okay, so points are labeled on the coordinate plane as an order pair in x comma y. So if we have 2 points, then we're going to call the first order pair x1 comma y1 and the second order pair x2 comma y2. So let's go ahead and get started. Let's start with the distance formula. What is the distance formula? Okay. To find the distance between 2 coordinates on the coordinate plane, you got to use the distance formula. The distance formula is, and here it is, d equals, okay, d is for distance, equals the big square root. Big square root goes from here all over everything. Okay. All right. What do? Basically, you take your x values and you subtract them, and whatever you get for the difference, you square it. So in this case, we say x2 minus x1. If you make the mistake and do x1 minus x2, you're going to be okay because you're squaring it, and squaring it's going to get rid of that error for you. Okay, so you subtract your x values and square, and then you subtract your y values and square, and then you add those squares together. Okay, so just think about this: you subtract, square, and then add. Okay. Remember that distance is never negative. So all of your answers should be positive in this case, because when you square anything, you're going to get a positive, and square this over here, you're going to get a positive. Positive plus a positive is a positive, and the square root of a positive is still going to be positive. So the distance formula is d equals the square root of parentheses x2 minus x1 squared plus parentheses y2 minus y1 squared, and you're going to take the square root of that. All right, here's an example. Okay, work it out from the beginning to the end. I have 2 order pairs. I have 8, negative 2, and I have 10, 16. Okay, now you can plot those on your graphing source there. You can go to the online calculator that we've been using this semester and plot those out. And what we can do is we can find the positive distance between those 2 points. Okay, this is x1, this is y1, this is x2, this is x2, this is y2. So what we're going to do is we're going to write down the distance formula and we're going to substitute in. Okay, so I take 10 and I subtract 8. So 10 minus 8, and I'm going to square it, and then 16 minus a negative 2. Okay, now be careful with your minus and negatives. Remember, you have to keep all the rules that you know about algebra in the back of your mind because you need to use them. So 10 minus 8 becomes 2. 16 minus a negative 2, if you go bam bam, it becomes 16 plus 2, and you get 18. Then you square both of these, you're going to get 4 and plus 324. So you're going to get square root of 328. And you take the square root of 328, you're going to approximately 18.11. Okay, so it's really easy. It's a plug and chug process, but be careful on things like this, 16 minus negative 2. Those are where you're going to make your mistakes. Okay, so how can we apply the distance formula to the stuff that we already know? Okay. So why are we talking about this if we just talked about triangles? Let's look at another example relating to triangles. All right, so the example says, in triangle ABC, the coordinates of the vertices are A, negative 1, 4, B, 5, 1, and C, 2, negative 2. So what we're asking here is this triangle isosceles? Is this triangle a right triangle? So we have two questions here that we can ask. Both of these are based on the sides. We need to find the distance of the sides. We need to find the lengths of the sides. So what I put down here is I put down my isosceles game plan. If the triangle is isosceles, then what we need to do is we need to find the length of all the sides and then to look and see if any of those lengths are the same. So to determine if a triangle is isosceles, we need the length of the sides. We need AB, we need BC, we need AC. To find the length, we use the distance formula 3 separate times. Okay, so this is what I do here. Now you can pause the video and write down this information, but you need to go AB, BC, AC, and we use the distance formula 3 times. Okay, so I said 5 minus negative 1 here, and then 1 minus 4. Okay, I said 2 minus 5. I said negative 2 minus 1 here. I said 2 minus negative 1. I said negative 2 minus 4. Substitute, plug and chug. Remember, minus a negative becomes plus a positive. And don't forget to square and add your stuff together. And you should get positive answers all the way down. So for AB, I get 6.71. For BC, I get 4.24. And for AC, I get 6.71. Well, look at these two, AB and AC. They're exactly the same. And if they're exactly the same, then that means the triangle is isosceles. So I can say triangle ABC is isosceles because two of the sides are congruent to each other. Okay? But now I also ask if the triangle was a right triangle. Okay? So go back to the original problem here. The coordinates of the vertices are that. Okay, we already know that from the previous slide here, previous two slides. But now I'm going to see, is the triangle right? So my game plan is the same. I still need to know all of the sides. But what I'm going to do is I'm going to use the Pythagorean theorem to test to see if it's a right triangle. If I plug into the Pythagorean theorem and it makes a true statement, then it is a right triangle. Okay, so let's look at it. Now I don't have to do any more work. I've already found the distances already. I found AB, I found BC, and I found AC. So 6.71, 4.24, 6.71. Okay. Remember that the longest side has to be the hypotenuse. Well, in this case, the longest side is shared by two sides, 6.71 and 6.71. So I'm just going to pick one and make that my C value. And I'm going to plug into the Pythagorean theorem here. So if I plug in 6.71 here, then that means 6.71 and 4.24 are my legs. Okay, and really and truly, I should put a question mark right here because I'm testing to see if these are correct. Okay, so I square all these decimal numbers here, and I get 45.0241, 17.9776, and 45.0241. Add these up, I get 63, about 63, and here I get about 45, and you can see that they're not equal. So if it does not work in the Pythagorean theorem, we cannot say that this triangle is a right triangle. Okay? Notice that I also worked this out by using the square roots. Because the Pythagorean theorem works with squares, I can easily take the square of a square root. Square root of 45 squared just undoes the square root there for you. So it just becomes 45. Square root of 18 squared just becomes 18. Square root of 45 squared just becomes 45. Add those together and I get 63 and 45, and of course they're not equal to each other. So the triangle is not right because the Pythagorean theorem does not work or is not proven to be true. Okay? So that is a great example of why we're using the distance formula here. I can ask you many questions. Is the triangle scalene? Is the triangle equilateral? Is the triangle isosceles? Is the triangle a right triangle? Okay, all by using prior knowledge, okay, including the Pythagorean theorem. This is the triangle, and I plotted it out here for you. I used Geometer Sketchpad here for you, and just to prove to you, I plotted the points, and then I drew the segments and did the measure of the segments on Geometer Sketchpad, and it works out, proves that it is an isosceles triangle. And you can see that these two sides look to be the same, okay? But you can also tell that the triangle does not appear to be right at all. So our math does hold up there with the picture. All right, with this video, I'm going to leave you with one example, and you're going to try it on your own. Okay, now it's your turn. In triangle LFO, the coordinates of the vertices are L, -2, 3, F, -6, -1, and O, 2, -1. Is the triangle an isosceles triangle? Is the triangle a right triangle? So what you need to do is you need to use the previous example. You need to find all the distances of the sides, and then you need to test out, is it isosceles? Is it a right triangle? Okay. A hint, by finding all the sides, you're going to see if two of them are the same, to see if it's isosceles. And another hint for the right triangle part is that you're going to take the distances and plug them into the Pythagorean theorem. Okay? So you should have that example ready for me tomorrow, and I look forward to seeing it from you. Thanks, guys.